This video is a review of Year 9 content about finding unknown sides and angles in trigonometry using trigonometric ratios. Now, this only works in right-angled triangles. The word we use to remember the trig ratios is SOHCAHTOA. Sine theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. Depending on what information you're provided, you select one of these trig functions to use to solve the problem. Here are a couple of examples. We'll start by labeling the sides. The opposite side is opposite the angle. The hypotenuse is the largest side, which is opposite the right angle, and the adjacent is this other side. So the two sides we're interested in is adjacent and hypotenuse, so we're going to use cos theta. So cos theta equals adjacent over hypotenuse. Now we're going to plug in the values that we have been given. Cos of 27 equals x over 11. Now, rearranging this formula to find x, we've got x equals 11 times cos of 27. You can type this into your calculator and you will get 9.8 centimeters. So this is our value for x. Let's do another one. Label the sides. We've got our opposite angle, we've got our hypotenuse, and we have the adjacent. So the two sides we're interested in is O and A, so that is 10. So tan of theta, which is 53, equals opposite over adjacent, so 71.3 over x. Now, rearranging this equation to find x, we're just going to switch the x and tan 53. So we'll get x equals 71.3 over tan 53. Typing this into your calculator, the value for x will be 53.73 centimeters. Let's have a go at finding some unknown angles. To find unknown angles, we will use the inverse trig ratio, which you can select on your calculator by pressing the second button, or it might say shift here, and then the trig function that you're interested in. The inverse trig ratio will look like this. It's the trig function with a little -1 in the top right-hand corner. So we'll start off the same way by labeling our sides. We have our opposite, hypotenuse, and adjacent. We are interested in O and H, which is sine. So the sine theta equals opposite 1 over hypotenuse 2. Now, rearranging this formula to find theta, we're going to go theta equals the sine inverse of a half. Typing that into your calculator, you will get 30 degrees. Same thing over here, we have opposite, hypotenuse, adjacent. The two we're interested in is adjacent and hypotenuse, so that will be cos theta, which equals 1.5 over 2.5. So theta equals the cos inverse of 1.5 over 2.5. Typing that into your calculator, you will get 53.13 degrees. Now let's have a look at a problem question. A diagonal cut of length 2.85 meters is to be made on a rectangular wooden slab from one corner to the other. So let's start by drawing a diagram. It's a rectangular slab, so I'm going to draw a rectangle, and we have a diagonal cut of 2.85 meters. We can see that this is going to be a right angle. The front of the slab measures 1.94 meters, so that's going to be this side here. Calculate the angle with the front edge at which the carpenter needs to begin the cut. So that will be our angle here. might just change colours so that we can have a go at this question. We're going to approach it in the same way by labelling the sides first. So we've got the side opposite, our angle, we've got the hypotenuse, and we have the adjacent. Since we have information about the adjacent and the hypotenuse, we're going to use cos theta, which is 1.94 over 2.85. Rearranging this formula, we have theta equals the inverse cos of 1.94 over 2.85. Typing this into the calculator, we get 47.1 degrees because we want it to one decimal point.